Welcome to my YouTube channel. Today we are going to solve the Leetcode problem maximum area from this diagonal rectangle. So let me explain you what problem is saying. Like problem is saying that you are given R1 and till Rn means these are rectangles whose length and breadth is given L1, B1, Ln. Okay. Now what you have to do is like you have to return the area of rectangle which has maximum diagonal length. Okay, and suppose it says that like if there are two equal means like maximum is 5 and another rectangle comes which has also a diagonal equal to 5. So in that case you have to compare the area, and the whichever area is greater then we have to return that thing. Now so what we have to do is like how can we use this information. So we are given length and breadth. Let's take second example. So like you are given a rectangle of size 4 and 3 orgone symmetry. It is 4 and 3. Now how can we use this information to get the diagonal? So diagram can be obtained using Pythagoras theorem, that is root of x square plus b square. But catch here is like if we know d square, then also we can compare. Like if you have two number 25 and 26. So in this case, you always know that the square root of 26 would be somehow greater than square root of 25. It doesn't matter how by how much or whatever, just we can compare it. Okay, right? So now going back to approach how to approach this question. Suppose we have R1, R2, and R3. I'm not taking exact numbers. Let me just go and give you a pseudocode type example and we will just type it because it is simple problem. But okay, let's do it. So suppose we have R1, R2 and R3. Suppose it has diagonal 5 and it has length 4 and 5. Don't go on this exactly. Just try to see it as a maximum. Let us consider it. It is MX. That is maximum diagonal. Okay, now again this also has diagonal which is equal to MX like in exact terms. But it has dimension, let's say 6 and 7. So area here is 20 and area here is 42 because what is the area of rectangle? It is L into B, right? So we have to return this one, means the we have to return the area. So we will return area, maximum area which is 42. So just let's quote it. So what we will have here is we have we have like max is equal to int. This would be our answer, and like we have ref equal to this is equivalent. This we will use to keep the previous maximum area, or the area we will use it to store the exact area of the rectangle whose diagonal is maximum. Now that is also start with interim, and also you can see that constraint here is variable, so you can use it any algorithm like in terms of complexity, but we are going to use big of and I will explain you after coding. Okay, now just we will iterate over the dimension array 2D array. So let's say auto add I dimensions. Next part we will just have current area, that will be I of 0, that is left, star I of 1, that is left. Sorry for that. Okay, now what we have to do is like we have to check the current diagonal. So let's it be int d. D is like what it will be I 0 star I 0, that is length into length, plus I 1 star I, and that is breadth into length. Now but there are two cases we have to handle. Like if our diagonal is greater than mx, then we have to just directly update the max equal to diagonal, and the area which stores the area we have to return to be the area of the current rectangle. And let's store it. Area current is equal to I 0 star. Oh, we are having current, sorry for that. We will store update that to become. Now hence what can happen is like if d is equal to mx, like we have the current diagonal equal to the maximum diagonal. In that case we have to check our area. So if ref is greater than uh, means like previous area is greater than current, greater than equal to current. So in that case we just have to do nothing. So we have to just update it. Another case like if current area is greater than ref, then we have to do one thing, like we have to update ref equal to current, and diagonal will be same. Now just work with the ref. Now let's try to run it. Let's check for some error or whatever which can okay, so it is constant. Now let's submit it. Okay, it is accepted. Now going over the complexity, we are just using a for loop which is up to the length of dimension which can be at max 100. So it is one loop running big of 100, and everything else like max and all everything is comparison, and which is big of one operation. So overall the time complexity is big of 1. Thank you. Please like, subscribe this channel and comment below for any